P and Q represent two parallel straight wires carrying currents into the plane of the paper. P and Q exert a force on each other, which row shows the force on Q.
Yeah, which one? So they are in the same direction, right? The wires are conducting currents in the same direction, right?
Uh,
They are saying into the plane of the paper, right?
yes,
So they are in the same direction. Then if they are in the same direction, they should attract according to our learning, right?
yes.
Yeah. So according to our learning, they should attract each other. So the answer should be D,
So which one?
Dhaka, Dhaka. Actually, in our next topic, topic 22, you will learn it more, how it is D. Okay, that time we will discuss. Now, question 9. Question 9. What is the answer?
Sir, don't know.
Yeah, the arrows on the field line show the direction of the force on N pole. Okay, actually, we understand one thing. That is, arrows start at North Pole and into the South Pole, right?
Yes, sir.
And also in compass, the arrow is shown for North Pole, isn't it?
Mm, yes.
So using those two ideas, we can get that arrows are actually indicating the North Pole. Okay?
Yes, sir.
Okay, 9. Okay, now question 10.
So C.
Yeah, soft iron, metal of the core made. And if we say coil of wire, that is made from copper, right?
Yes.
Yeah, 11. Yeah, this one you know.
Sir, A.
Correct. Well, we discussed, right? Then 13. 13 you know now.
13 B.
Yes. Then 14.
Sir, D.
Bangladesh,
Dhaka.
Dhaka. So it should be clockwise or anti-clockwise? Magnetic field lines. Magnetic field lines according to right hand grip rule. That will be clockwise or anti-clockwise.
In this question, it should be clockwise, right?
Okay, if it is clockwise, should it be D or C according to your compass?
C.
Yeah, because your uh, field lines direction will follow that, right?
Yes.
The compass one. Okay, so it should be like this, right?
Yes.
So it should, the direction of the compass is in this direction. It's clear.
Yes, sir.
Okay, now next, this one actually, this one you will also understand in our topic 22 we are going to discuss today. So that time we will discuss. Okay, this one is skip now, and also this one, question number next. Okay, three floating compasses also you'll understand from there. Now this one 16 you can understand here. 16 the same way we can understand the way we understood the previous one. This one 14. You can draw the magnetic field lines and then you check how it's working. Can you read this question 16?
Two parallel wires carry currents in opposite directions. Three plotting compasses are placed at the position shown. The currents in both wires are reversed. How many compass needles change direction?
Yes, so it's shown like this. The way we see the compasses is shown like this. Now, if we reverse the current, what happens? If we reverse the current, uh, it will be like now it is clockwise, right? This one. Hello.
Yes.
Then it will be anti-clockwise if we reverse, right?
Yes, sir.
Then both the compasses will change the direction here, isn't it? And this one will be downwards. Then now it is anti-clockwise. That time it will be clockwise, isn't it? Then
Yes.
it is also changed. So I think the answer should be Dhaka. What do you think? What do you think?
I don't think the middle one will change. Like, it's the same thing if you reverse. It
Like
should.
like if you draw here, now it is clockwise, right? So if it is reversed, then it will be changed, right? The compass,
The, the both wires are reversed.
yeah, both compasses are here. First, you think this one. So both the compasses are reversed here, right?
Yes.
Then you think of this. If it is reversed, it will come to this direction, isn't it?
But why will it become reverse?
Uh, because you see, it's now the way it's showing it is clockwise, right?
But the other wire is also reversed.
Yeah,
Like it says both
other
wires are
let us finish one, then we'll go to other wire. Huh? If you change it, then it comes uh, anti-clockwise, right?
yes.
So if it is anti-clockwise, then it's coming like this. Huh? Here is this direction, and here is opposite direction, right? So two compasses changed, right?
Yes.
These two compasses changed. Okay, we got here two compasses changed. Okay, see. Uh, okay, this one is done. Now After these two compasses direction changed, then we think about this one. Okay, so already these two changed, right? LT.
Yes.
Okay, already these two changed. Now come to this one. So if it is reversed, it is now uh, anti-clockwise, so it will be clockwise, isn't it? If it is clockwise, already this one is done, right? It's coming to clockwise
Yes.
direction, but this one is left, so it will be also clockwise, right? Isn't it? So three changed,
Yes.
isn't it?
Yes.
All three changed. So our answer should be Dhaka. Is it clear now?
Yes, sir.
Okay, thank you. If it is a little bit confusing, but if you go in cool brain step by step, then it will be clear to you. Then we have next, which one? This one, right?
Yes,
Yeah,
sir.
this is a nice question. 17. 17. Can you read the question? Can you read, please? If you read, then it will take
The,
care of. Yeah, read. Read question
the
17.
diagram shows an alarm system. What happens when battery P is disconnected?
Battery P is disconnected. Yeah. So now it's connected. But if it is disconnected, then what happens? First, you say if it is connected, then what happens?
It will be A.
If battery P is connected, you just describe what happens. Uh, we will go for option later. First, you discuss what will happen, that how
The
it's working.
i- iron armature will go up because the
Mhm.
iron core will be magnetized. That's why.
Yeah, yeah, very good, very good. So, if P is switched on, then we have iron armature, iron core magnetized, then iron armature is attracted to the iron core, right?
Yes, sir.
And our bell is not ringing that time, isn't it? Bell circuit is disconnected if iron armature is connected to iron core, right?
Yes, yes,
So if now battery P is disconnected, what happens? Iron core becomes demagnetized.
yes,
Then iron armature will fall down.
yes,
Then bell rings.
yes,
Then our answer is A. Is it?
yes, sir.
18 also related to two parallel wire conductors. We will discuss it next when we will discuss topic 22. This one also 19 related to parallel wire conductors. 20. 20 we discussed. Yeah, 20 is done, right?
Yes, sir.
Yeah, 20 is done before. So now we are doing a structured part. Okay, do the structured part. Yeah, can you read the question?
Figure 1.1 is the new view from above of a stationary and small compass on a laboratory bench. State the material from which the compass needle is made.
Yeah, compass needle is made.
Iron, soft iron,
Huh?
soft iron.
Compass needle is about permanent magnet, right? Compass, in compass we are using the magnet that is permanent magnet, right?
Permanent. Yes, sir.
So for making permanent magnet, should we use iron or should we use other?
Other,
Which one we can use? Can you name one?
the nickel.
Nickel we can say steel or we can say cobalt, right? Anyone. Okay?
Yes, sir.
Okay, then continue next part.
Describe how the small compass is used to plot magnetic field lines in the region surrounding the magnet.
Yeah. What can we do for drawing the magnetic field lines? We discussed, right, in class from your book.
Ye- yes, sir.
So, according to that, you write in 3 steps. What should we do? So, have you written?
Sir, I can understand how to write it.
Okay, you don't understand how to write it. So, our first task here is to place the compass near to a pole. Either you can place it to North Pole or South Pole, right? Isn't it?
Yes, sir.
So if you keep it closer to North Pole, then you'll see this arrowhead is opposite of this north, right?
Yes.
Then here you mark a point. So how to write it? The first point is place the compass closer to the North Pole and observe the direction of the compass. Mark mark the direction of the compass with a dot. Okay, is it clear?
Place the compass closer to the North Pole.
Hmm. Then mark the and observe the direction of the North Pole in the compass and mark it. Mark the direction of North Pole on the paper, right? Here
Yes,
we
sir.
should keep a paper, then there will mark it. Then we place the compass uh, either side of the in the middle of the magnet here, like here. Okay, so here we will also do the same thing, huh?
Yes.
And do this process for um, for the South Pole and some other points on the other side of the magnet. Okay, so this
Yes.
is second step. This is second step done, and third step is joining these lines. Uh, Joining these lines and also uh, show the arrow. Okay, and also draw arrow to show the direction of the field lines from north to south. because your North Pole has shown direction, right? Everywhere.
Yes.
So that direction you should show with arrow. So last point is to join lines and showing the direction with arrow on the lines. So you got it now?
Yes, sir.
Yes, done.
Yes, sir.
So what you wrote, can you tell me the steps?
Place the compass closer to the North Pole, then mark the direction of the compass on the paper. Then place the compass in the either sides and South Pole and repeat the marking. Then join the lines and draw arrows to show the poles.
Okay, very good. Then C now. Continue C, please. Yeah, read.
An unmagnetized iron bar PQ is placed near to the magnet of the laboratory bench. The iron bar is initially at rest and the magnet is moved to the right very slowly. When the magnet is a short distance from the bar, the iron bar moves very quickly to the left towards the extreme where the iron bar is attracted to the magnet.
Yes. Why the iron bar is attracted to the magnet? So what should be the answer?
Because the north pole of the iron bar is facing the south pole of the magnet, and as they are opposite poles, they attract each other.
Okay, so how the iron bar is getting that pole from its, it was far away. It was not closer to the magnet. That time also it has pole, or when it brought closer to the magnet, that time it got pole.
When it got closer,
Okay, so when it got closer, then what happened? It got magnetized, right?
yes, sir,
Isn't it? Yeah, it got magnetized, and this magnetism we know it is called induced magnetism, right?
yes,
So what should we say? So we'll say that iron bar becomes magnetized due to induction. This is first point. For first mark, you have to say this. Then you say what you said. Then you write what you said, that and P becomes an N pole, right? Isn't it?
yes,
So the side P becomes North Pole. Then finally you say unlike poles attract. Okay.
yes.
So these 3 points for 3 marks you should mention. So you mentioned, 2 points. The other point I added, right? That is
Yes.
magnetized due to induction. Done. Your writing is done.
No, sir.
You're right. Finish writing, then read what you wrote. Yes, Silti, are you done with writing?
Yes.
Okay,
Yes.
read now what you wrote.
When the iron bar gets closer to the magnet, it is magnetized by induction. The p side becomes north pole and gets attracted to the magnet as unlike poles attract.
Excellent. So read now question two, loudly.
Two flexible iron strips WX and YZ are placed close to each other inside a solenoid. The NW of WX and the NZ of YZ are held firmly in position. The switch is closed and there is an electric current in the solenoid. NW of the flexible iron strip NW of flexible iron strip WX becomes magnetic S pole. State the type of magnetic pole produced at X, Y, and Z.
So W becomes S pole,
S
right?
pole, yes,
W becomes S pole. So X will become North pole, right?
yes,
And Y will become
South pole,
South pole. Then Z will become
North pole.
North pole. Okay. So you got it.
Yes, sir.
Very good. Then next,
State and explain what happens to X and Y because the flexible iron strip are magnetized.
yeah,
They
what
attract
happens
each
to
other.
X and Y? They will attract each other, right?
Yes.
Okay, then next we
A
have
relay operates
hmm,
A relay operates a switch in one circuit using the current of in a different circuits. State one example of a relay used in this way and explain why a relay is used.
yeah. So one use I told you, that is starter starter motor of a car, right?
Yes,
So that one is used to avoid high voltage in the
yes,
other circuit, right? So you will
yes.
write it, write the example and also why we are using that.
So I read that it is used in the starter motor of a car to avoid. Uh,
High voltage in the main circuit or the second
yes.
circuit. It's clear now. I'm
Yes.
giving you another example. You can also write that, though it's not necessary here to write, but for your understanding and increasing the knowledge, you can write that is second. You write number two, in nuclear power station. We also use relay to operate nuclear power station. And why we are using that? So that we can avoid radioactivity, right?
Yes.
We can control it from far away. Then, then question three, right?
Yes. A vertical solenoid with an iron core is held in a wooden clamp above a laboratory bench. The solenoid is connected in series with a battery, a switch S, an ammeter, and a variable resistor. There is a voltmeter in parallel with a solenoid.
Yes.
The, the current in the solenoid magnetizes the iron core so that the lower end of the core is a north pole. On figure 3.1, draw the pattern and indicate the direction of magnetic field in the region surrounding the iron core.
So you first, uh, you see, they said on figure 3, draw the pattern and indicate the direction of magnetic field in the region surrounding the iron core. So we'll use here which rule? Right hand grip rule, right?
Yes, sir.
So according to right hand grip rule, where will be the north pole here?
The
Your
bottom.
current direction is from positive to negative, right?
Yes.
So your current direction will be like this. I'm showing you the current direction. It's like this, right?
Like, where is the direction? Like the thumb. Where should be the
Yeah.
thumb?
Yeah. Where is the thumb direction? It is down or up?
Uh, it
Check.
is
You will
down.
know it if you know the current direction in the wires, because your other fingers are showing you the current direction, right?
Yes.
So you fix it there first. Your current is going from positive to negative this way.
Yes.
Is from here to here. Mm, this direction current, right? So your direction of current in the wire will be like this, huh? Like this.
Yes.
So if it is like this, then your other fingers are shown in a direction that uh, your thumb will be downwards, isn't it?
Yes.
So your thumb will be downward. That means your north pole will be here, right? You will here label north pole N. Okay, north pole is here. So if you can find the north pole, you can draw the magnetic field lines, isn't it?
Yes.
Now your magnetic field lines will go from north to south this way, right? You draw at
Yes.
least four lines, left side two lines, right side also two lines, huh? Here they should not cross each other. The way you will draw, they will be closer at the poles. This way they will be closer at the poles. It will be this way, okay? And the direction you also show here. If you show at least one line on one line the direction, it will be enough, okay?
Yes,
This
sir.
way. So if you draw this way, then you will get 3 marks, okay?
Yes, sir.
It's clear?
Yes.
Any confusion?
No,
No
sir.
confusion. You're clear about this. The next part we have, okay, can you read the next part?
The student holds an iron cylinder against the bottom surface of the iron core in the solenoid. When he releases the iron cylinder, it stays in contact with the iron core.
Yes. So what should be the answer of it?
The iron cylinder gets magnetized by induction, and
Hmm.
and its side that is closer to the north pole becomes a south pole, and it attracts to the magnet solenoid.
Yeah. Unlike poles attract. You
Yes,
mentioned it as unlike poles attract. So you also mentioned that unlike poles attract and complete the answer quickly.
yes, sir, done.
Okay, then what you wrote, can you say again?
The iron cylinder gets magnetized by induction, and the side closer to the north pole becomes south pole and gets attracted as unlike poles attract.
Yes, very good. Then continue the next part, part two. The switch S is open, right? State and explain wherever
Yes,
the iron cylinder remains in contact with the iron core.
no, as the iron core loses its magnetism.
Excellent, excellent. So write it.
Yes, sir, done.
Yeah, continue for.
Suggest a material that is used to make permanent magnet cobalt.
Okay, then next.
When there are no magnetic fields present, the needle of the plotting compasses point due north in the earth magnetic field. This is shown in figure 4.1.
Yes.
The plotting compass placed close to a permanent magnet first at A and then at B as shown in figure 4.2. The magnetic field close to the permanent magnet is very large than the magnetic field of the earth. On figure 4.2, draw needles in the two circles. Draw needles into two circles to show the direction in which the compass needle points when the compass is at A and B.
Yes. So how will show the needle here?
At
How
B, it
will
would show towards the opposite of North Pole.
in B?
Yes,
Yes. Then in A, it will not be like straight forward. It will be a little bit corner, right? In
yes,
A.
sir. And the North. Okay, understood. And so the needle should be like arrows or the one in the previous page.
Yeah. You just draw the like this way the needle you are having. So you give one arrow. Huh? Simply one arrow you give here. Huh?
Okay.
This way you give arrow, and here it will be like this. Huh? From here. Okay, like this. Huh? Because
Yes,
the
sir.
magnetic fields here are going like this. Huh? Okay, got it?
Yes, sir. Describe an electrical method that is used to demagnetize a permanent magnet. You may include a diagram in your answer.
So you got how many methods?
So, 3.
What are the three you got?
Hammering, heating, and passing through a AC current.
It is, are they saying demagnetize, right? So which one will be you you will be using for
Uh,
demagnetizing? The AC one will be better, right?
yes, sir.
So you can draw or you can give the description you got.
Yes.
Yeah.
So, is there any mark for drawing?
They said you may. So here no marks directly for drawing, but your points may come in also in drawing. Other than writing, you can draw and label, then you may get 3 marks, all the 3 marks. Okay.
And so, I'll write that
Mm-hmm.
place the permanent magnet in the AC current and then remove it. Like,
Inside the solenoid, okay, which is carrying AC current.
yes.
This way, right? AC supply, alternating current supply. Actually, we are placing it in the solenoid, right? Into the solenoid and taking it slowly from the solenoid, isn't it?
Yes.
So do it, please.
So I wrote,
What you wrote?
place the permanent magnet in the solenoid of a AC current and remove it slowly from it.
Very good. Then question 5.
Figure 5.1 shows a solenoid made from wire round a plastic cylinder. A current in the solenoid produces a magnetic field. Draw the pattern of the magnetic field lines inside and outside the current.
Now you can do it, right? Where will be North Pole?
At the negative end.
Yes, then. So you draw it, huh? You can draw it now.
I'll draw lines, two lines in both direction, and upwards and
And
downward.
show the direction also, huh?
But it says fill lines inside and outside. What would be the inside one?
Walaikum salam. So the inside one means like if your n is here, huh,
Hmm.
n is here, then the field line is going inside, right?
Yes,
And if your south pole is here, then the field lines are coming out from here, right?
yes,
So this way they are mentioning that you are showing the continuous line which one will show both inside and outside of the cylinder. Is it clear?
yes, sir.
So done this part.
Yes, sir.
Then question 6.
Figure 6.1 shows a part of an electric bell. A switch and a cell are in series with a length of wire coiled around an iron core. The switch is closed and a current in the wire produces the south pole and north pole. At the ends of the core, as shown in figure 6.1, magnetic poles are also produced in small iron bar placed near the ends of the core. On figure 6.1, mark the north pole and south pole produced an iron bar and with an S mark with
So
an S the position of south pole produced in iron bar.
so where will be your south pole? Where will be your north pole? You understand, right?
Yes, sir.
The upper part of the iron bar will be north,
Yes.
and the lower part will be south. So this one is done. Then next, continue.
State and explain what happens to the iron bar once it is magnetized. It gets attracted to the solenoid as unlike poles attract.
Yes. Then next, last part.
The switch is open and there is no current in the wire state. What happens to the magnetic poles in the iron bar?
Yeah,
The poles are the poles are gone.
yeah. That we will say that poles, the iron bar may demagnetize, right? And
Yes,
the iron bar is no more magnet. It does not have any poles, right? So you will say poles gone because iron bar is magnetized, demagnetized, right? Or loses magnetism. Is clear?
yes,
So done. We are done with this worksheet except some MCQs regarding those parallel wire, right? Current
yes,
carrying
sir.
wire. This one 19 we left, 18 we have, and we have 15. We have after 15 we have 8. Okay, so this 4 question we will discuss when we will have the theory of topic 22. Okay, that is
Yes,
electromagnetism. You join after 10 minutes. Okay,
okay, sir.
12:05 you join.